I'm sure all of you remember the historic BP oil spill of 2010. Well, throughout the BP oil spill crisis, over the course of 87 days, more than 200 million gallons of crude oil was pumped into the Gulf of Mexico, making it the largest oil spill in U.S. history and one of the most devastating environmental disasters the U.S. has faced to date. 16,000 total miles of coastline have been affected, including the coast of Texas, Louisiana, Mississippi, Alabama, and Florida. Time has shown that the use and transport of oil continues to increase, and as a consequence, there have been an increased numbers of leakage and spill accidents. Unfortunately, the results have shown severe pollution to our oceans and environment that ultimately lead to a detrimental decrease in valuable resources, especially in more coastal ecosystems. Treating oil spills has remained a difficult and controversial process to approach. New methods for cleanup are being introduced and tested more and more as environmental policies and regulations emerge. Conventional cleanup techniques are not adequate enough to solve the problem of massive oil spills. Nanotechnology plays a new and important role that defines how much spills are being cleaned. The methods used in cleanup prior to nanotechnology are divided into two main categories: chemical methods and physical methods. Chemical methods such as nanodispersion are used as a means to control and decontaminate waters where spills have taken place. Dispersants alone do not reduce the amount of oil entering the environment, but are used to enhance evaporation and allow more rapid breakdown of oil by bacteria. With this process comes many environmental risks. Dispersants often create a toxic environment for fish by releasing harmful oil breakdown products into the water. Approximately 1.84 million gallons of dispersants were used in the BP spill. Physical methods include sorbents, skimmers, and booms, with sorbents being considered as the more promising approach. Sorbents made from nanowire membranes are super hydrophobic and extremely absorbent. This allows for the material to absorb toxic pollutants such as crude oil without also taking in water. These nanomaterials have been shown to absorb up to 20 times their weight in oil. Researchers have taken to these materials by tackling the question of how to effectively remove the oil during spills. Robots such as Sea Swarm by MIT have been developed to move fluently across the surface of water collecting oil. Conveyor belts on these robots are covered with an oil-absorbing mesh of nanomembranes, allowing them to absorb the toxic materials. A couple examples of carbon nanostructures are exfoliated graphite and carbon nanotube sponges. Each category presents its own advantages in remediation of crude oil spills. Exfoliated graphite, for instance, is extremely valuable when it is necessary to clean up heavy grades of oil. With this advantage, exfoliated graphite also has drawbacks of decreased sorption capacity and drastically decreased oil recovery as the number of cycles used increases. Carbon nanotube sponges are extremely light and tough and selectively absorb oil from the surface of water. Nanosponges have been shown to absorb up to 180 times their own weight in oils and solvents. With a density of 5.8 to 25.5 milligrams per centimeters cubed, these sponges are extremely buoyant, making them ideal for oil cleanup. Once absorbed, the oil can be removed by simply squeezing or combustive measures. It's clear to see that the use of nanotechnology is an easy and effective way to properly mitigate oil spills such as the Deepwater Horizon spill. That spill alone pumped 4.9 million barrels of crude oil into our oceans, leaving nearly 1,000 kilometers of shoreline contaminated. 230,000 squared kilometers of fishing grounds in the Gulf of Mexico were closed for fishing, and approximately 6,800 dead birds, turtles, reptiles, and mammals were collected. The total price tag for the cleanup? $40 billion. Without measures taken in the nanoscale of cleanup, it is safe to say that that number, along with the number of dead fish, birds, reptiles, and mammals, would have increased dramatically.